Hello everyone. I'm going to do two examples of simplifying expressions that have trig functions in them. Now, when we are simplifying these, we have a couple options, and one of the best options to use is taking all of the trig functions and rewriting them in terms of sine and cosine. Once everything is in sine and cosine, we can normally combine some things together, or we get some trig functions that cancel each other out. But that is a good method to try right away, and it's actually the one we're going to use for this first example. So here I have the cosecant of theta times the secant of theta minus cotangent of theta, and I want to simplify this as much as possible. So the first thing I'm going to do is I'm going to take all three of these and I'm going to rewrite them in terms of sine and cosine. So the cosecant, this is the reciprocal to sine, so this is 1 over the sine of theta. Secant is going to be the reciprocal of cosine, so this is 1 over cosine of theta. And then subtracting away the cotangent, which is the same as the cosine of theta divided by the sine of theta. Okay. Multiplying these two together, we can write this as a single fraction. So I'm going to write this as the sine of theta times the cosine of theta in the denominator. And then cosine of theta divided by sine of theta. So now I have everything in terms of sine and cosine. And I have the two fractions here, and I just want to combine these together. So to do that, we do need a common denominator. So this one has a sine and has a cosine. My second fraction just has a sine. So let's multiply top and bottom by cosine to get that common denominator. Okay, so 1 over sine and cosine. And then in the second fraction, it's multiplying the numerators together and multiplying the denominators. Cosine times itself, we get cosine squared. And then we have sine of theta, cosine of theta. Now we can combine these together. All right. So we've made some good progress. We were able to combine everything together into a single fraction. Now we want to take a look at this and see what other things we can use. In the numerator, we did end up with this cosine squared. So when I see that, the first thing my mind jumps to is the Pythagorean identities. So we know that sine squared plus cosine squared is the same as 1. I'll just write that over here as a little note. So sine squared plus cosine squared, this is the same as 1. If I subtract cosine squared from both sides, I get this expression here. So 1 minus the cosine squared, that's going to be the same as sine squared. So let's substitute that in. So this is the same as the sine squared of theta, and then sine of theta, cosine of theta. Sine squared, this is sine times itself. So this is the sine of theta times the sine of theta. So that means I have a sine of theta in the numerator, and I have one in the denominator, so that common factor can simplify. So this will cancel out with this, and I am left with the sine of theta divided by the cosine of theta. And that expression, we can simplify that down to just tangent of theta. So starting off with our trig expression here, rewriting everything in terms of sine and cosine. We did have to use the Pythagorean identity, but then everything simplified nice to tangent of theta. Okay, let's move on to the second example. The second example here, everything is already in terms of sine and cosine. So what we're going to do right away is just combine these fractions together. It is going to be similar to what we were doing in the first example, but a little bit more involved because our denominators are pretty different here. So here we have 1 minus sine, and then the denominator, the second one, is cosine of theta. So I need to get these to match. So for this first fraction, we're going to multiply top and bottom by the cosine of x. So I'm going to have sine of x, cosine of x, and then I am going to multiply that by another cosine of x, and in the denominator, 1 minus the sine of x times the cosine of x. Okay, kind of messy so far, but as we move along, things should work out pretty nice. So then we have minus, and then for our second fraction, I'm missing the 1 minus sine part, so we're going to multiply top and bottom by that. So in the numerator we'll have 1 plus the sine of x and 1 minus the sine of x. And then our denominator is going to be the same as what we have here. Okay, so there's the common denominator. Now we can combine these fractions together, but before we do that, I just want to clean this up a little bit. Here I can multiply these two together. That's going to give me a cosine squared. And in that second fraction, 1 plus the sine of x and 1 minus the sine of x, these are exactly the same. The only difference is 1 is plus and 1 is minus. So that is the difference of perfect, this is going to be the difference of perfect squares. So the shortcut is 1 times itself is 1, and then we have minus sine times itself, so sine squared of x. You could multiply this all out and you would see that those middle terms do cancel out, and this is what you're left with. And then our denominator, okay. Now if we keep going, we ended up with 1 minus the sine of x. I do have that sine squared there. And one thing I did notice in the first example is I can use the Pythagorean identity to substitute that out. So 1 minus the sine squared of x, that is the same as cosine squared. And I'm going to combine this all together now too. So we have sine of x, cosine squared of x, and then combining our numerators together, minus, substituting that, we get the cosine squared of x. And that is all over our common denominator, 1 minus the sine of x and the cosine of x. Okay, let's see what other simplifying we can do. In the numerator, I have two separate terms here separated by this minus sign. They both have a cosine squared in them, so we can factor that out. So factoring out cosine squared of x. In this first term, I'm left with the sine of x. In the second term, everything is factored out, so we're just left with minus 1. And then I'm going to reverse the order here. So then we have the cosine of x and 1 minus the sine of x. And we're almost done. We have two cosines on top, one in the denominator, so one of those will simplify. And then if we look at what we have in parentheses here for the sine, these are very similar, but this is just backwards. So actually what we can do is either in the numerator or the denominator, I can factor out a negative 1, and that will switch the sign on both of these, and it'll make it look exactly the same as what we have in the denominator. So if I factor out a negative 1, we end up with a positive 1 and then a negative sine of x. So factoring out that -1 here, now these sets of parentheses are the same, so that common factor will simplify. One of these cosines will also cancel out, and all we are left with is the opposite of the cosine of x. Okay, hopefully you found these two examples helpful, but as I said at the beginning, one of the best methods we have for helping us along as we do this is rewriting everything in terms of sine and cosine. It's a good place to start. Other than that, we are using just our normal simplifying rules. We're combining things together, we're factoring if we have to, looking for common factors in the numerator and the denominator. And beyond that, we do have the trig identities that can help us out as well. Things like the Pythagorean identities here.